Okay, Yun, so tell us a little bit about the electronics, the control code, the tool chain for the control code on a
Okay.
circuit mill.
So far what we just established is GCTRL and
Define it.
GRBL.
Okay, define
And
those.
GCTRL is essentially the control software, and it includes graphical user interface. And essentially, it's a bunch of text. It's code that you run on IDE integrated development environments such as processing. So you put the code into processing, you open it up in there, and then you click run, and you get this GUI. And you can, from there, jog the CNC circuit mill with the arrow keys and page up and page down, or you could press G and hold down, and it'll open up a new window, a search window, for you to search up from your hard drive a file, a G-code file, so you could
So
stream that.
you're operating in processing?
Yes.
Okay, and how do you get the code that processing uses?
Okay. So the code that the GCTRL code is available from SourceForge, and processing as a download is available from their home site. When you have the, say, G-code streaming file or even the jogging control, what happens between your computer, the signals are sent via USB cable to the Arduino Uno microcontroller, and the Arduino Uno, you have to, before doing this process, flash in software known as GRBL, well, it's firmware, and GRBL is a G-code interpreter. So essentially what the GRBL is doing inside the Arduino is it's taking those G-code signals and converting them into step and direction signals for the stepper drivers.
Okay, tell me the relationship between G-code and processing. G-code is what you input into processing?
Yes, G-code is what you input into the processing GCTRL, and it goes through the computer into the microcontroller, and GRBL interprets that G-code and converts it into step and direction.
And now tell us the latest on what's the tool chain with which we're going to get the G-code to run with.
Okay, so what we need then at this point is to start off with a G-code that relates to a particular desired circuit that we want to mill out. So essentially what we need is three aspects. One is circuit editor, which is you have an idea for a circuit and you edit it out.
Show an example. What's an example of a circuit editor we could use?
Example is KiCad or GEDA, GEDA or KICAD. Those are popular ones, evidently, based on online research. And from that circuit editor, a schematic editor, you convert that circuit file into a Gerber file, which includes the PCB layout. So now it's not a circuit schematic anymore. Now it's
an actual circuit layout, the actual tool path that your mill will take.
Yes. So essentially it's the traces on the board that you can now, at this point, see. And you take the PCB file and put it through software such as PCB G-code or PCB to G-code, and then you convert that PCB layout into a G-code file with the last piece of software.
Okay, but as far as we know, this is pretty complicated or cumbersome right now. Why is that?
For one thing, there's sparse documentation in some of these steps, and you're using multiple pieces of software, which if not compatible with each other, and also platform issues. For instance, KiCad works on Windows and Linux, but the G-code, PCB to G-code does not work on Windows, so you can't have the full tool chain for Windows, apparently, if you're using PCB to G-code. So issues like that, compatibility and documentation.
Okay, and on Linux, like say we're using Ubuntu, what was the thing that you used and how well did that work? Well, you haven't gone through the whole tool chain, have you? And why not?
No. Because for one thing, it's the documentation is sparse.
On which particular ones?
Oh, documentation is sparse, especially on the PCB to G-code, as far as I've inquired, and the process of manufacturing the CNC circuit mill just took higher priority at that point.
Now, also with the particular piece of interpreter from the circuit files to G-code, you have to put in the specific parameters of your milling machine, right?
Yep.
And do you see problems on that based on your design? Is your mechanism different, like how you actually implement it? Will there be do you foresee issues on the actual translation to a particular machine like the open source ecology circuit mill?
Currently, the software and electronics is very similar to what Snaplock used, so I think given that they've been able to do custom settings for their frame design, it won't be too much of a problem because because I've inquired into PCB to G code. The settings are readily configurable.
Mm-hmm.
It's just, of course, the documentation is a bit sparse.
And what are we doing to address the issue of the software toolchain?
Daniel said he could work on it, and we're going to be establishing that and documenting that. And after establishing upon which we'll be able to essentially go from a circuit idea to the mill board.
So you're building a team of collaborators to help define the toolchain and implement it.
It's great to have co-developers working on this together.
So developers pipe up. We need to refine this toolchain. That's an invitation. Okay.